So today we are going to learn about circuits with memory. So prerequisites for this combinational circuit, prerequisite for circuits with memory or sequential circuit is combinational circuit. Combinational circuits are the circuits in which we have more than one inputs A, B and C, and we have one output. Like y is the combination of A, B, C, function of A, B, C, and we take no feedback from y, we take no feedback from y to the input, and it is only the combination of A, B and C. But in day-to-day life we use sequential circuits. For example, in our laptop, the time is updated every minute the time is updated. So how it is updated? Like it is 126 now, but after a minute it will be 127. So to be 127, it should remember that it was 126 before a minute. So there is a need for memory in our day-to-day life. So we can access the memory, we can create a memory for the previous value, and we can take it as a feedback so that we can get the new value like 127. So for that, let's take the example of the simplest feedback circuit, a NOT gate. In this NOT gate feedback circuit, there is a NOT gate and there is one A and Y, and A and Y both are shorted, and we are not giving external inputs to the circuit. Let's assume there is a disturbance, a noise like this, which cause a voltage coming in A. So let's assume it is 0. So we will get 1 volt at Y, as Y is A bar, A complement. So as A and Y are sorted, so this one will come to this, we will get 1 at A after some time delay TD. This TD is the time delay in time, that is after how much time Y is appearing in the circuit. We are giving input 0 to the NOT gate, and after how much time Y is appearing in the circuit, it is the time delay TD. TD is generally in nanoseconds. So after Y appeared in the circuit, as it is short circuited, so 1 will come to the input side A, and for 1 we will get 0 after a TD time, and after we will get 0, it will transmitted to A. For 0 again we will get 1, and this cycle will be repeated. So this is called a ring oscillator, as the value is oscillated over a cycle. So we are plotting the graph. It is 0, it is 1, and the width will be TD, as the TD the time delay. The important point here is we are not giving any input here to the circuit. So just a disturbance comes in the circuit, and it is playing the important role. It is the creator of the oscillation. So here it is a problem that TD is in nanoseconds. So we cannot observe the square of in oscilloscope. We need to connect a machine called oscilloscope, and there is function generator in the oscilloscope. So in oscilloscope we can see the graphs of the outputs, but in this case TD is in nanoseconds, so it is a very less time, and we cannot see the square of due to high frequency. We cannot observe the square of So now we can move to a little bit complicated circuit. So let's go into a butterfly structure. In butterfly structure, there are two NAND gates, and the name suggests why it is called as butterfly structure, because it looks like a butterfly. So assume that it is a noise which creates 0 volt at the input side of NOT gate. So we'll get 1 at the output side, and this one is short circuited with the input, so we'll get 1 at this due to the noise, and we'll get output at this. This is not oscillating. The value of 1 and 0 are not oscillating until the noise doesn't change. If the noise is changing to updated value 1, then we will get 0 here, and if 0 is and 0 will be transmitted here, as these are short circuited, and we will get 1 here. So until the noise is not changing, we are getting the same value at the output. So it is a bit stable until the noise is not changing. So here the problem is that we are depending upon the disturbance, we are depending upon the noise. Here the creator is the noise, but as engineer we want to take the control in our hand. We should be the operator, we should be the creator. That's why we use NAND gates for this. NAND gates and NOR gates, we know those are universal gates, and we are using in this circuit. We see that A and B are the input from the user, so user has the control now. So let's draw the truth table for this circuit. Suppose we have A, B as input, and Q plus as the updated value of Q, and Q is the previous value of Q plus. We are taking feedback from Q and we are updating Q plus. So for when A, B is 1 1, let Q old value, let us assume that old value of Q is 0. So before that, I need to make you understand about I want to make you notice a point about NAND gate. When A and B are the inputs to a NAND gate, the output of the NAND gate, when A is 0, B is 0, it is 1. When A is 0, B is 1, it is 1. A is 1, B is 1. A is 1, B is 0, it is 1. A is 1 and B is 1, it is 0. The important thing to notice here is that when a input is 0, the output is 1. We need not care about the another input. When the one input is 0, the output will be 1. We need not care about the another input. So in this circuit, we have assumed that Q is 0. So as Q is 0 here, so Q bar will be 1. As Q bar will be 1, here we will get 1, and we have assumed that A is 1. So 1 1 in NAND circuit we will get 0. So updated Q value will be 0. Let assume old Q value is 1. So updated will be, let's assume old is 1. So it is 1. So we have got 1 here. B is also 1 1. For 1 1 in the NAND we will get 0 at the output side. We are getting 0. So here it is 0, and if one input 0, the output of an NAND gate will be 1. So updated value will be 1. So here we have seen that Q plus is same as Q. We are keeping Q, or Q is stored when A and B is 1 and 1. So similarly, when A is 0, B is 1, for A 0, B 1, I need to clean this. If A is 0, one input is 0, that means Q will be 1. We don't need to care about the another input. When A is 1 with 0, Q bar will be 1, Q bar will be 1. As Q bar will be 1, here we will get 1. And we have A equal to 1, so we will get Q equal to 0. We will get Q equal to 0. If both are 0 0, this is a case which we need to understand. If both are 0 0, for A equal to 0, we will get Q equal to 1. For B equal to 0, we will get Q bar equal to 1. And this is a case where both Q and Q bar are equal, and it can't happen. So it is a forbidden state, forbidden or stupid state. So we have seen the circuit with two NAND gates and two inputs A and B, Q and Q bar. Let's give it one more degree of freedom called as enable. We are giving one more degree of freedom. One is S, one is R, and one is enable. Degree of freedom means one more input. So this is the circuit for a gated SR latch. So when enable is 0, this is A and B. A and B both will be 1 and 1, and for both 1 and 1, we know that it will Q plus will keep the memory and it will give us Q. So we don't need to care about S and R when enable is 0, as Q plus will always store the memory. When enable is 1, that's why we will now discuss about when enable is 1. When enable is 1, S and R both are 0, A and B will be 1 and 1, as the property of NAND suggested. So for A and B 1 and 1, it will store the memory and it will give Q plus. The updatable value of Q will be Q. When S is 0 and R is 1, if S is 0, then A will be 1, R is 1, and enable is 1, B equal to 0. For A, B equal to 1 0, it will be 0 from this table. When S equal to 1, R equal to 0, S equal to 1, R equal to 0, it is 1 1, it will be 0 and it will be 1. So for 0 1, it is 1 from this table, so it will 1. When S, enable and R all are 1, we will get A and B both are 0. So for 0 0, it is forbidden state, so it is forbidden or stupid, so we don't take it. So here it is exercise. It is an exercise for us. We need to find out the truth table for gated D latch. It is called gated because we are applying these gates here, and D latch because we are using this D as input, and in SR latch, gated SR latch, we are using S and R as input. That's why its name is gated SR latch, because S for set. When S equal to 1, Q is set to 1. When R equal to 1, Q is reset to 0. That's why it is SR latch, set and reset latch. So let's find out the truth table for the gated D latch. Enable, D and Q plus. Enable, when enable is 0, A and B both will be 1 1. So we don't care about D, Q will be Q. So next, when enable is 1 1, D is changing from 0 to 1. So when D is 0, A will be 1 and B will be 0, because 0 1 due to not get, it will be here 1 and it is 1 1 1, after an AND it will be 0. So for 1 and 0, from this truth table, for 1 and 0 we will get 0, and for when enable is 1 and D is 1, we will get 1 here and 0 here. So B will be 1 and 1 1, it will be 0. So for 0 1, for A equal to 0, B equal to 1, we will get, from this truth table we can find out, A equal to 0, B equal to 1, we will get Q equal to 1. We will get Q equal to 1. So I hope you understand about the circuit. Thank you.